Good morning all. So today we are going to discuss what is meant by a active power, a reactive power and apparent power, and what is mean by this power triangle and power factor, how this power triangle and power factor and other different type of the powers, how they are related to each other. So those kind of concept we are going to discuss in this class. So as we know that in our in practical loads we use in our real-time applications. So all these loads which we are used in our practical applications. So all these are the mostly inductive loads. So what is this inductive, or what is meant by this inductive loads is nothing but, so it is the load which is has the inductance and a combination of a resistor. So this is what the called the inductive load. You can say it is called the inductive load. So the example for this inductive load, what we using, that the ceiling fan is one of the best example for your inductive load. If you want to write what is the Z relation here, the impedance relation, you can write this is nothing but, you can say r square plus XL square. So this is the impedance of this kind of inductive load, or sometimes also you can write R plus JXL. So this is also called a impedance, So therefore, if we take the phasor diagram for RL concept, so this is look like a RL single phase circuit, isn't it? So it is look like a RL single phase system. It is look like RL single phase system. So if you take the phasor diagram here, if you draw the phasor diagram for this RL circuit, and if I take V as a reference, if I take the voltage as a reference, therefore my current lags, my current I lags with the angle pi. So with the angle of pi. So this is the concept we have studied in case of RL series circuit. In case of RL series circuit. So here my current can be it can be divided into different components here. So this is the different component I can take, or I decompose into different component here. So this component I can write as I cos pi. I am simply applying a trigonometrical concept here. Triangle I have, and I know the I, so I can write this line. What could be this line is I cos pi. And what is this line is nothing but this one, I sin pi. So my current I resolved into two components. The two component, one is in x-axis direction, another is in y-axis direction, where at the x-axis direction the one of the component is I cos pi, and in y-axis direction the another component, the resolution of the another component is I sin pi. So this is what I want to talk here. If suppose for given this concept, if I multiply a voltage variable to each component, then what could be the resultant here is, so this is nothing but, if I'm multiplying here, this is V, this is V, and this is V. So this is V. So this is what my voltage multiplication giving to each component. Now what is the resultant diagram we are getting here is, so this is my resultant diagram I am getting here. I can say this is my resultant diagram. So this is nothing but I cos pi, and this is Vi, this is Vi sin pi, and this is simply Vi, and this is the angle has pi. So this is called a power triangle. You can say this is a look like a power triangle here, isn't it? It is a some kind of power triangle. You can name it power triangle, where what is this Vi, what is this one, we have to identify here. So Vi cos pi, so this component Vi cos pi, I can say it is a active power, and Vi sin pi, I can say it is a reactive power, and Vi is a apparent power, So we'll see it in detail, what is meant by apparent power, what is meant by this active power, reactive power, what are the significance of these powers in electrical terminology, we're going to discuss here. So let us take the first one is apparent power. So you take the sentence here. So I can write the apparent power here. It is a total power. It is a total power that appears to be transferred between the source to a load. Is called a apparent power. What is meant by this is, so this is the kind of explanation for apparent power. Otherwise I can write this is an actual sense, this is, or I can say, so I will take one example and I will explain to you. Suppose I have a load, some kind of load, but I don't know inside this box what could be there. So this is some simple circuit I am taking here. So this my voltage source is giving this V, and some current I is flowing through this. So if I use the ammeter, voltmeter, I can measure the voltage, isn't it? If I use the voltmeter, I can measure the voltage. If I use the ammeter, I can able to measure the current. I can measure the voltage and current by using these two devices. So here what happens is my source assumes that it supplies the power. A source supplies the power, that is nothing but V into I. So this is what the power which is supplying, that kind of assumption is taken by the source. So this is I can write. So this is in sense assumed to be the supply power by the source, so that it is called a apparent power. Because my source is assumed to be supplying some power, that power is nothing but Vi power. So this Vi power I can say a apparent power, and I can take here, so therefore the apparent power is not a actual power. Apparent power is not a actual power. Apparent power is not a actual power. So that is what the explanation here. So whatever the power measured by my voltage and current, that is nothing but that P is equal to some power, that is nothing but V into I. So my voltage source assume that V into I, this is the power which is it is able to supply. So that is the assumptions taken by my voltage source, but this is not a actual power. So this is a apparent power. Then what could be the actual power? Then what is the actual power here? This is going through the circuit. So actual power or true power, I can say true power or actual power, or you can say active power. So this is what we have to define now. So the power which is actually consumed by the circuit is called a active power. The power which is actually consumed by the circuit is called active power or true power or actual power, you can say here. So what is the true power here is, if you want to define the true power here is, suppose if you take the true power definition here, the true power is nothing but the current component is in phase with the voltage that produces the true power. So what is meant by this? You take this statement, the current component is in phase with the voltage produces the true power. So that is the statement has given. So I can explain this one here. So as we know this is my vector diagram. We know this is my I is coming something like this is pi, and my current has different component here, isn't it? So this is my different component, but along with this voltage I cos pi is the current, one of the current component which is going in phase with this voltage. So this is what the true power. So it is, I can write here, the true power is nothing but the true power P is can be written that V into that voltage into the current component which is in phase with this voltage, that is called a, this is called a true power or active power, or you can say the actual power, you can say it is. So here current component is in phase with the voltage. So that is because of, you can take here note here, this current component is in phase with the voltage because of resistance is present, because of the resistance value present in the load. So that is the meaning of this. So now now my active power, true power is nothing but the actual power which is consumed by my circuit. This is Vi cos pi. Now if you take the our impedance diagram for your RL load, this is R, this is X, this is Z, and this is the theta, you know. So I will do some relation here. V is nothing but I into Z, and I can write this is I. Instead of cos pi, I will take this cos pi. I will write it is R by Z, R by Z. So Z will be going to cancel. So P is equal to I square R. So what is mean by this? So whatever the true power or actual power, true power or actual power, which is producing here because of this resistance, because of this resistance. So we can conclude here that the conclusion here is that so whatever the power loss, power loss or the true power happens in the system, happens in the network is because of resistor, because of the resistor. So that is the meaning of this true power or active power. Then so this is what the explanation, how what is meant by the true power, actual power and active power, and is that power is what kind of quantity is consuming this kind of power. So this is what the explanation. If you go for the definition, then what could be the definition for my active power here is, so you know this expression, isn't it? P is equal to Vi cos pi. So this is the expression we know. So I can say the definition for active power is nothing but it is the product of voltage, with the current component which is going in phase with the voltage. It is the product of voltage with a current component I cos pi, with a current component I cos pi. I cos pi is nothing but it is going in phase with the voltage. So that is the definition you can write. So I can write, so it is the product of voltage and in phase current component, in phase current component, in phase current component. That is what the definition and the explanation. So this true power is a what full power or useful power. This is the useful power or wattful power, you can say wattful power. So whatever the power, the active power, true power, so this is the very useful power, which is what the actually consume the load. Whatever the load which consumes that power is called a active power or true power. So that is the meaning of this. Now we'll go for the next power is a reactive power. We'll see what is this reactive power. So if you see this one, so this is my diagram I know, and this is the diagram we have. This is Vi, this is Vi cos pi, and this is Vi sin pi, isn't it? So this is what the I have the next thing here. So the reactive power is denoted with the Q. Then the Q I can write, this is nothing but I sin pi, isn't it? So I sin pi I can write here. It means that it is the product of, my reactive power is the product of, this is the definition I am writing, product of voltage and the quadratic current component. The quadrature current component. Quadrature current component. Quadrature current component. What is the quadrature current component? This one. this is the quadrature current component, and this is the voltage. The product of these two, if you do, then you are going to get that the reactive power. So this is the definition. So what is the significance of this reactive power is this power neither consumed or does any useful work in the circuit. This power neither consumed nor does any useful work in the circuit. So because here the power consumed by the L or C is a reactive power. So I can say here, so take the note here. So the power consumed by the L or C, inductor or capacitor, is nothing but a reactive power. But what about the actual power? What about the active power? Active power or average power? The average power or you can say active power consumed by the L or C is 0, isn't it? So this is what we have proved many times. Because why it is 0? Because so L or C, it will take the power for first quarter cycle, and for second quarter cycle or another quarter cycle it is returns the power. So average of the active power is nothing but 0. So this is anyhow this concept we have already covered in the previous lectures. If you go through that lectures, the single phase AC system with RL and RC, so there we have talked why the average power is 0 in case of RL and RC or L and C. So those concepts we have gone through that. So anyhow you go through that. So this is what I want to talk here. So if you again recall the diagram for this one, suppose I'm taking, this is the waveform diagram I'm drawing here. This is the diagram drawing for a pure inductor. It is the diagram drawing for a pure inductor. Then this is the current and voltage waveform, isn't it? So this is the voltage waveform, this is the current waveform, and this is what it is going. And what is my power direction here? My power, it is the instantaneous power is nothing but V into I. So this is what we are going to get. So if you go through that, you will be able to follow this one, how we are getting this one, right? So I think you have already covered this one. So you can see this one, how we are getting. So like this is we are getting. So this is what the power, this is the power we are getting. So for this, for one quarter cycle, for this is one quarter cycle, 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 this is what quarter cycle for this. So for one quarter cycle your inductor or capacitors takes the energy, and for another quarter cycle your inductor and capacitors returns the energy. Therefore the average of power consumed by that average of the average power consumed by your inductor and capacitor is 0. But what kind of power it will consumes? But in actual sense, the what kind of power it consumes is it is going to consume that reactive power. So this is the reactive power consumed by your L and C. So this is what the concept we need to understand here, where this reactive power can be written as Q is equal to Vi sin pi. So this is what you know. So this is nothing but my reactive component, isn't it? So reactive component, or you can say quadratic component, reactive component or quadrature component quadrature current component you can say. So if you want to write Vi sin pi, then this is nothing but volt amp reactive. So this is the unit for your reactive power, and this reactive power is a wattless power. wattless Wattless power. So these are the different terminologies you need to understand. And I hope you have gone through the active power, reactive power, and apparent power. What is meant by the apparent power? What is meant by the reactive power? And what is meant by your active power? Three power you have till now you have covered, and I think you have got the clarity of that. Now let me to draw a power triangle here. So I will draw the power triangle. So this is the power triangle I am drawing for my sense here. So this is my I can say this is Vi cos pi. This is nothing but P, and this is my Q, Vi sin pi, and this is pi, and this is S is called Vi. So these are the different names you can give here, and you can write the values here. So I will write the values here. So I will write here. So this is called reactive power, and the unit for reactive power is volt amp reactive, and this is called active power, active power, and true power. Unit for this one is watt, and this is called apparent power, and unit for this apparent power is volt amp. Unit for this apparent power is volt amp. So this is called the power triangle. This is called the power triangle here. So from this you can get the many relations, and you can solve any kind of numericals here. So let we discuss here what is this power factor. So what is mean by a power factor here? So you know what is the power factor is nothing but cos pi. This is the term, cos pi means it is a power factor. So if you define this, it is a cosine angle between the voltage and current. What is the angle between the voltage and current is called the power factor. So that is the definition of that one. So you can write also, isn't it? So here if you want to find what is the power factor cos pi, what are the different expression you can have? R by Z I can write. So if it is my triangle is there like this, pi R XL and Z, if it is like this, then my power factor can be written as something like this. Or cos pi also can be written as P by S. I am writing power factor definition from here. So apply this one, you will get this one. This is nothing but watt. This is nothing but volt ampere again. So this like that you can broad the relation of the power factor from that your impedance triangle as well as your power triangle. So we will take one numerical here. So with that numerical you will get more clarity on this power triangle, power factor, and how to find what is meant by apparent power, and all those kinds you will be able to get from here. We'll see how to get this numerical so that you can easily understand here. So let us take the numerical. A current I, the value is 14.14 sine omega t minus pi by 6 flows in an electric circuit when a voltage of V is equal to, has given 141.4, sine omega t is applied, then determine the power factor, active power, reactive power and apparent power. So this is what we have to do here. So you can get the solution here. So if you see this current voltage equation here, this is 141.4 sine omega t, and my current is 14.14 sine omega t minus pi by 6. So by seeing this voltage and current, I can say that this is a lagging power factor or inductive load, I can say. So my voltage is here and my current will be here. This is my current will lag voltage by this pi by 6 angle. So that is the 30 degrees angle. It is by seeing this expression I can able to identify which type of load it is, whether it is inductive load or capacitive load. Obviously minus pi by 6 it is, so it is an inductive load, therefore my current will lags voltage by this angle. So that is what information I am getting. Then what is the power factor here? The power factor is equal to cos pi, so you apply this one, power factor cos pi. So cos of what is pi? Pi is nothing but pi by 6. If you do this one, you will going to get 8.66. Whether it is leading power factor or lagging power factor, it is a lagging power factor because my current is lagging voltage in a inductive load. So I always write lagging power factor. If my current leads the voltage, then that is a capacitive load. There we can write power factor with a leading concept we can write. Okay, fine. We'll go to find what is the VRMS voltage. So if you want to find VRMS, Vm by root 2, isn't it? Vm by root 2 I'm writing. This is 100 volts we are getting. Now find what is IRMS here. So that is nothing but Im by root 2. What is Im here? What is this Im? Im you are getting 14.14 by root 2. Do this one, 10 amperes you are getting. Now what is the active power? What is the active power? It is nothing but Vi cos pi. What is the reactive apparent power? S is equal to V into I. What is my reactive power? This is Vi sin pi. So these are the different formulas I have. What is this V? 100 into what is I? 10 into cos pi is equal to 0.866. Do this, you will get 866 watt. Now go for this one. This is 100 into 10. You are getting 1000 volt amperes. Here go. Then it is 100 into this 10 into sin pi. Sin pi means sine 30 degrees, isn't it? So if you do this one, you have to get 500 volt ampere reactive var. You can say var. So this is how you can getting these different values, and you can able to find the voltage, this power factor and active power, reactive power and other kind of factors here. So with this I will end up for the today's concept. We will, and next class we will come with the another fresh topic.